Hello everybody. Hopefully you are watching this video during the weekend, and I hope you're having yourself a fabulous weekend. If you're not watching it on the weekend, you're probably watching it in class on Monday. So just look up and say, "Hey Elliot, hey kids." So anyway, today we are going to be solving absolute value inequalities. Now, I'm not going to talk about the theory of this right now, the why. I'm just going to show you the how. We're going to talk about the why in class on Monday after you've watched this video. So just watch the how, and then based off our how conversation, the how examples I'm about to show you on Monday, we'll fill in with the why we do it this way. But whenever I solve this problem, absolute value x minus 3 less than or equal to 6, what confuses people in these problems is this x minus 3. To remind me of what I need to do in this problem, I think of a similar situation, but a little bit easier. So instead of just absolute value x minus 3, what if it was just absolute value x less than or equal to 6? Well, in this scenario, on a number line, if I think about the numbers that are less than 6, well, 5 is less than 6, 4 is less than 6, 3 is, 2 is, 1 is, 0 is certainly less than 6. It does include 6, so I have this filled in circle at 6, and it starts heading off this way. Now what about negative 1? The absolute value of negative 1 is still less than 6. The absolute value negative 2, 3, 4, 5, all less than 6. And the absolute value of negative 6 is 6, so that's equal to 6. And then once you get beyond 6, like the absolute value of negative 7 is 7, and that's greater than 6, so it stops at negative 6. So absolute value of x less than or equal to 6, the graph looks like this. When the graph looks like that, algebraically, that means it's negative 6 less than or equal to x less than or equal to 6. That's exactly what that statement means. So this situation, this is what you algebraically do to it. So I noticed that the right side, x less than or equal to 6, is just like it reads. So that's exactly what I'm going to do over here on this problem. I'm going to go x minus 3 less than or equal to 6, just like it reads. And then the inequality, it continues off in the same direction. And then instead of a positive 6 over here, I noticed they wrote a negative 6. So it would be the same thing here. So by understanding the simple situation, I'm able to understand the more difficult situation a little bit more. Whenever you have these inequalities of this variety, you need to add to all three sides of the inequality. And if to get x by itself, I would add 3 to all three sides. X is now by itself. 6 plus 3 is 9. Negative 6 plus 3 is negative 3. So I have negative 3 less than or equal to x less than or equal to 9. Now when you graph these on your number line, include 0 and the two numbers that you are graphing. And in this case, the answer goes from negative 3 all the way to positive 9. And because it is equal to it, we go filled in circle. Okay. If you have any questions on this and you're watching this in class on Monday, pause that video, ask that question, and once you're happy with the answer, then move on to example 3. Example 3, let's make this as hard as possible. Absolute value 5 minus 2x. Close absolute value less than or equal to, I don't know, 10. Oh wait, I don't want to go less than or equal to because that's what we did for the first one. For this one, let's just go less than. And did I even mention? In our absolute value inequalities today, sorry I didn't mention this before, we are only doing less than absolute value inequalities today. These both were less than, this one's less than. All of these less than graphs always work out the same. So if you're confused on what to do with this one, think what would happen if instead of being absolute value 5 minus 2x, what if it was just absolute value of x less than 10? Well, if it was this, if you think about the graph, all the way from positive 10 to negative 10, all of these numbers have an absolute value of less than 10. And then because it can't be equal to, we have to go open circle there. So which means it'd be like -10 less than x less than 10. So same idea over here. I take this 5 minus 2x, I make it less than 10 just like it reads, and then on the other side I put the same less than sign, and I put this -10. And once again, I'm just showing the how. We'll talk about the why on Monday in class. Solve these inequalities at the same time. If I subtract 5 from all three sides, I get -15 less than -2x less than 5. And then when I divide both sides by -2, or all three sides by -2, excuse me, negative divided by negative is positive 5 over 2. Inequality flips over because I divided by a negative, so greater than x, greater than -5 over 2. I get kind of confused when these inequalities look like this, so I always like to write it the other way around, so I have the negative first, so it's -5 over 2 is less than x, which is less than positive 5 over 2. I've made a mistake, haven't I? I shouldn't get the same number here. Let's see. When I subtract 5 from all three sides, this should be -15, which would be positive 15 over 2. So over here I should have positive 15 over 2. All right, graph it on a number line. Include 0, -5 over 2, and positive 15 over 2. The answer goes all the way from -5 over 2 to positive 15 over 2, open circles on both. And then finally, interval notation answer, -5 over 2 to 15 over 2, soft brackets on both because you cannot be equal to it. Okay, everybody, that's the only part of the lesson that you must have before starting in on practice problems on Monday. I do have one special case scenario, so if you want to get your advanced learning on, let's look at the special case scenario. That would be example 4. Let's say I had absolute value x plus 7 is less than, because these are all less than in absolute value inequalities, less than -8. Okay, think about this for a minute. When would the absolute value of a number be less than a negative number? Absolute values are always positive, no matter what number you put in there. 0, 10, 100, 1,000, Mr. Elliott. -53, -100, -1 billion, negative my daughter Kyla. That doesn't make any sense, but this would still be positive. So when would a positive number be less than a negative number? The answer is never. Never going to happen. So this answer is no solution. And you can just look at this and know right away that the answer is no solution. But the algebra does actually, if you try to solve this one out algebraically using the same technique, the problem flops. And let me show you where. If you write it, if we treat it like all the other problems, that we take the inequality and we write it as -8, and then we include, finish it off on this side with the opposite of -8, which is +8, and then we solve all these together. So I subtract 7 from both sides. I get 1 is less than x, which is less than -15. So think about this. I need a number that is greater than 1. So if I think about the graph here, I need this number to be greater than 1, and I need this number to be less than -15. Tell me something, students. When is a number greater than 1, but at the same time less than -15? Never. That's when. So the answer is no solution. How do you graph a no solution graph? Not like this. A no solution graph looks like this. It's empty. Interval notation, you just say no solution at this point. So these are the two answers that you would give: an empty graph for the graph and a no solution, because there's no number in the universe that when you take the absolute value of it, it would be less than a negative number. So no solution. And if you spot it at the beginning, you could always just say right away, hey, the answer is no solution, and this is my answer. You do not have to go through this work if you can spot it right away. But the math does fail itself, and it fails itself right there. Anyway, I hope you found special case example interesting. I certainly did. And once again, this lesson was just meant to show you all of the hows to do absolute value inequalities when it's less than. Then on Monday in class, we're going to talk about the whys these problems work out the way they do. And then we'll also talk about greater thans on Monday. And then Monday night's lesson will be how to solve the examples of how to solve greater than inequalities. Anyway, I hope you guys have a fantastic rest of your Sunday, or Monday if it's Monday. Look up and say, hey, Elliot, I'm done with the video. Have a great day. I'll talk to you later. Bye-bye.